We are going to talk about microservices, and in particular, we're going to talk about the collaboration between these microservices and how to design that. The focus is about doing that over HTTP, and I'm going to sort of talk about and explain why that's actually a pretty good choice and sort of a lightweight thing that you probably have in your environment anyway, and then later on you might want to do something else or whatever, but it's a really good starting point, and just not introducing too much and just use what you have, because you can do it really well using HTTP. My name is Christian. I'm an independent consultant. I've been working with microservices a whole lot over the last, I don't know, 5 years or so with different clients, and sort of that experience from a number of different companies doing that and seeing those transformations towards microservices is of course what informs this talk. So it's the experiences from those things, or some of the experiences from those things pull into this talk. The same goes for the book you see there, the Microservices in .NET Core, very much based around that experience. And sort of also some of the same things that you'll see in this talk. So if this makes any sense to you, you can go to the bookstore and get that book. Yay. You also see some contact information there on that slide. They'll be at the end as well. So please raise your hand and ask questions as we go. But if you think of something afterwards, you can also reach me through email, Twitter, or whatever. And I'll be happy to discuss. Okay, so we're talking about microservices, and that seems to be all the rage, and we all have to do microservices. Yay! But then again, maybe not. Maybe it's not the silver bullet. So I'm going to preface a little bit before I get into the collaboration part, a little bit about what I mean when I talk about microservices, because it's such an overloaded term at this point. And I'm going to talk a little bit about why I think you should do it in some cases and why you shouldn't in some others. And then we'll dive into the collaboration between them. So first off, sort of my personal definition of a microservice is that a microservice is a service with one and only one very narrowly focused capability that a remote API exposes to the rest of the system. So a microservice is something that is part of a bigger system. It's also a service, so it's still service-oriented. I think it's mostly just a flavor of service-oriented, and we've sort of put the micro in front of it, and whether micro is really a good word or it should have been fine-grained or something else, that's kind of up for debate, I think, a little bit. But at least there's this sort of narrowly focused capability part that plays into this, that microservices tend to be and should be narrowly focused, so they should be very focused. It's kind of the Unix way of thinking, do one thing and do it well, applied to services. So I think that's probably sort of the big difference compared to sort of earlier iterations on what we thought service-oriented architecture was, that we maybe tended to look at some larger concepts back then, and sort of something that we might now see as kind of a system that we will then break into to microservices. And to get a little bit more concrete and to sort of and to introduce the running example that I'm going to use on the slides throughout the talk, this could be sort of part of a backend system for some chain of shops. That could be like the 7-Eleven chain of shops, and you might have a loyalty program where you can sort of get this little plastic card, and then every time you buy something, you get points, and then every so often you get a free cup of coffee or whatever, because you've spent so much money at their shops. So lots of chains have these. That could be sort of at least the first approximation of doing this backend system. You might have a loyalty program microservice, because that's sort of one capability going on in that system. There's some management around that loyalty program. Now, over time, you might actually break that down further, because you might find out that that's actually more than one capability. That's sort of a natural thing that we see with microservices happening over time. That you maybe start out with this, and then looks good. Then you sort of realize that there's actually sort of a set of capabilities or a set of things going on around the physical card and issuing that and putting a name of that and sending out new cards to people or whatever. And then there are some other capabilities going on around the business rules around the points. how many points do you get per purchase, and are there sort of other things? Do you make more points if you buy something at night than at day, or the other way around? There might be all sorts of weird rules around how you get these points. And do you spend them when you get something for free, or is it sort of just you move up and become a better customer? There's also all sorts of rules there, and that's quite sort of different things. The physical cards and the points, it turns out to be different things. So you would see this evolve, but sort of for the sake of keeping it a little bit not making it too overwhelming in the talk, I'm going to talk about it as this one loyalty program microservice. It is part of a system, and there are other microservices around it. So we see in the top left-hand corner, we have something called a special offers microservice. So you can think about this as something sort of back office type, where people within this chain of stores, they kind of decide what are the special offers that we are going to put on. We are going to say that you get a donut and a cup of coffee at a discounted price. Or we are going to say this week we have 3 Mars bars for the price of 2, or whatever. You put those up there. There's sort of a connection between those two, and that when we have these people with these loyalty cards, then you might sometimes target some of those special offers at them, so they might only be available to them, or it might be that you just want to identify that given a special offer, we want to figure out who this is interesting for. And then maybe we notify them, and that's what's going on in the bottom right-hand corner in the orange one. We have a notification microservice. So we could create a special offer. The loyalty program then sort of looks at that offer, looks at the population of people in the loyalty program, and figures out, okay, who are we likely to sell this offer to? And then we notify them somehow. Send them a push notification on our mobile app if they have that. Send them a text message, whatever it might be, and try to sell something to them. So already here, and these are only, as I said, this is sort of a first approximation of doing this, and it's likely that we over time will split some of these microservices into smaller ones. But already at this point, we see that in order to do just slightly interesting things like creating an offer and actually trying to get something to buy them, we have 3 microservices in play. So we do see that we are having some collaboration between these microservices before they do anything interesting. Right. This is already kind of jumping ahead a little bit, because I promised that I'd say a few words about why we want to do microservices. So I'm just going to return to that. And sort of the first and main point that I have experienced with the customers I have, at least, and this can be different for different sectors and different companies, but it seems to be that it's very much about enabling continuous delivery. And that's sort of the techie or developer way of saying it, because there's sort of an underlying reason behind this, because doing continuous delivery in and of itself is just sort of something that developers want to do. Businesses don't sort of sit down and put in their mission statement that they want to do continuous delivery. There's no point in that. They have something else that they want to do, but they want to do that something else in a quick way, and they want to be able to experiment, and they want to be able to turn around and do it in a new way and follow the market and so on. So all of these things are all the things we've been talking about for years and years and years with Agile, and it turns out that continuous delivery is something that if we get good at it, if we do it right, then actually that enables real agility for the business. And I think that is the underlying reason for a lot of companies that do microservices and do it successfully. There could be other reasons. Some look at some scalability components and so forth, but I think this tends to be at the heart of it. It's about that flexibility. So that's really a good thing that we can get from this. Then this is the clear number one of the ones that I have on the slide. So I'm going to go faster between the next ones. Another one is that we can get sort of highly maintainable services. Of course, you can still write crap code and shoot yourself in the foot, but these being narrowly focused, it's also possible to actually write them so that it's pretty obvious what they're doing, and you can sort of hold it in your head, and it's all fine and good. So you get something nice and maintainable. you get the possibility. You get the possibility to do that in any system, I think, I guess, but you sort of have something driving you towards at least sort of manageable sizes here, which makes it easier to have something maintainable. Ties into as well an efficient developer workflow. Solutions just aren't that big. It's not going to take. It's not like when you open up the solution, you go get coffee because it's going to take forever, and tests can be fast and so on. So these also plays into the flexibility and the quick turnaround you can get. You can get some robustness sort of by design into these systems. This is one where you can definitely also go the other way and shoot yourself in the foot. Microservices means that you have sort of highly distributed systems. So there's all manner of ways to fail. But, this is some of what we're going to talk about today, is that if you think about how that collaboration goes on, then you can build in some robustness. That means that you can survive even something in the system isn't working properly, the rest of it will still run, which is really good. So you can get some robustness just in there by design. And then I guess sort of on the scalability level, you also get a flexibility there that you can find the bottleneck and then you can scale that one out. You don't have to scale everything out. You can scale out the microservice that is actually the bottleneck. So I'm kind of guessing, since you're in a room listening to microservices talk, that these are things that you've probably kind of heard before as the good things around microservices. So I wouldn't expect that there's any big surprises at this point, but we're going to play a little bit back into these benefits as we go through the talk. Now, the flip side of that is, of course, that, well, it's not a silver bullet. It's not going to do everything for everybody. And the first thing is that distributed systems just are hard. So if we don't have sufficient complexity in the domain to sort of offset the complexity introduced by doing a distributed system, then we probably shouldn't be doing this. Because all the things I'm going to talk about, the collaboration, I mean, they are there because it's a distributed system. If we just didn't do microservices and we didn't need to distribute things for other reasons, for the ones that we just talked about, for instance, then this talk wouldn't even be there and we could just get on with our lives. And that would be kind of great in a way. But then again, we do want that flexibility. We do around the scalability, around the quick turnaround, and so on and so forth. So there are reasons for doing that, but you need a certain level of complexity in order to justify it. You're going to have a lot of services if you sort of go this direction. I'm not going to talk a lot about how sort of to scope microservices and find out which ones you need. Just sort of what I already touched upon. That it's usually sort of a journey where you get a first approximation and you have sort of a manageable set of microservices. Like on the slide we had 5 earlier, and that's not hard to keep in your head. You can understand the whole system. But already there, I sort of alluded that loyalty program is probably going to turn out to too big. So just off the top of my head, it was like the physical cards and the points, and there's probably more in there. It's probably more complex to actually implement a real loyalty program than I realized, because I haven't done that for real. And as with most domains, as you dig in, it turns out to be more complicated than you think. So you'll end up with a lot of them. So it means a complex production environment, lots of deployments, and that plays back into the thing about continuous delivery. Now the goal might be that flexibility, but you also need the continuous delivery in conjunction with microservices, just because the sheer amount of services you have mean that you are going to deploy a whole lot, and you're going to drown if you can't do it automatically and continuously. So you sort of bring in some complexities. You force yourself into some complexities by choosing microservices. You'll also see that sort of refactoring across microservices can be difficult. If you don't get those boundaries right, then you're in a situation where you have different code bases and different repositories, and you have different pipelines in order to deploy them. But now you need to move code from one to the other. That's just a lot more difficult than having it in one solution and have your IDE just do the move refactoring, and then boom, you're done. It's just a lot more coordination. Which is also why I think that the sensible way of approaching it is actually rather starting with slightly too big than slightly too small with microservices. So that's also sort of one of my well, it's not really on any of the slides, but it's one of the things I do want to say, that if you go into the microservice journey, you should err on the side of making them slightly bigger. You should rather say, okay, I'm going to start with that loyalty program, even though I think maybe down the road I'm going to split it up into more things, but I'm not sure yet. Then I'd rather start with the bigger one and split them later, because that's a smaller hassle than taking two that were too small and just are cumbersome to work with and putting them together. I'd rather go the other way around. But over time, you're going to get a lot of them, and that introduces some headaches. Okay, so with those warnings sort of out of the way, I'm going to assume that we are doing microservices, and therefore that we do have these hundreds of services, and that we do need to think about the collaboration between them. And what do I mean by collaboration? I mean any and all communication between the microservices. So in the example, there were some arrows, and that meant that there was a communication going on between these microservices. So every time they talk to each other in some kind of way, that's collaboration. And I find it helpful to split the collaboration into 3 styles. And styles doesn't have 3 S's in it, but it does on my slide apparently. It does today. Those 3 styles I think are useful to think about are commands, queries, and events. And again, you'll notice these aren't words that I just sort of made up. These are words that we've used a lot around software and in other contexts as well. And that's a good thing. These should be something we know about. Commands is one microservice asking another one to do something for me. Queries is one microservice asking another microservice for some data back. Give me this back. Asking a question. And events, which is kind of the most interesting one of the bunch, and the one that I'm going to recommend as your preferred way of creating a collaboration between microservices. Events are stuff that has happened. It's a past tense. It's a fact. It's someone registered with the loyalty program. It's not that they're going to register. It's that they did register. So when the loyalty program might decide to raise an event and say someone registered, then they are already registered. It's not something the other parts of the system can say, no, that's not going to happen. It already has happened. And that style, the past tense and the stating of facts, that turns out to give you some nice properties around robustness and scalability around these services. So if we look at the example again, we will see that we actually have a bunch of the different types of collaboration already going on. So I'm just going to see if I can point up there in the corner. We have some event-based collaboration already going on, and it's in the near corner over here. And down here we have some sort of get something about the user. That's a query. We have that down here as well. I'm going to point the other way. Over there we have some get, and that's a query. We also sort of have send out that notification, and that's a command. So we have on this slide already, we have some queries, we have some commands, and we have some event-based collaboration. Commands and queries, I'm going to talk about these in conjunction, and then after that I'm going to talk about events, because events is the one that is the odd man out. So commands and queries share the fact that they are synchronous. So if you send a command, you sort of say, do stuff, and then you sort of need the answer back that at least the other party has accepted to do that command. Whether they've actually finished that command and actually done it, that's kind of another question, but they've accepted that, yes, I received that command. With queries, I guess it's even more obvious that if you sort of ask that loyalty program microservice, how many points does this given user have, then it doesn't make any sense to not get the answer back. It's not really a query. You get the answer back, so it's synchronous in that sense. Now, last time I presented on these slides, I sort of got the question at this point, oh, but we can implement that request response over an asynchronous pipe. We can sort of do a message and then get a message back later. Yes, that's true. But that's, on a logical level at least, that's still synchronous in my mind. You wait for the response. So these are synchronous on a logical level at least. And they map nicely to HTTP. And so queries are pretty much just an HTTP GET if we do it over HTTP. Commands are pretty much just HTTP posts or HTTP put. So a GET, yeah, that's for asking for something, getting an answer back, and you are even allowed to cache it in a lot of cases and so on and so forth, and that's nice. Post and put, yeah, that's meant to change something on the server side, so that fits nicely with the command, go do this. I post a command up there. And already here, we are kind of starting to see that since HTTP is so ambiguous, no, not ambiguous, ubiquitous, and it's definitely already in your data centers, all tech stacks support it. It's just there anyway, and it's probably also one of the more stable things in your data centers, or where you have your server-side code running. It tends to often be. It's sort of it's a good choice actually to use it. It's there anyway. We don't have to introduce sort of another technology in order to do this. So just annotating this picture again, and I don't expect that to be any big surprises in this. I pointed out the get query, get loyalty points by user, and oddly enough, that's an HTTP GET to something with a user and some kind of user ID. I guess that shouldn't be any big surprise. We also have the command of registering a user that we have here, and that's an HTTP post, and that sort of maps as you would expect. And just to drive this point home, it's also pretty easy to implement. This little snippet of C# code uses the Nancy web framework, which is a nice little, well, not actually little, but nice, lightweight, easy to use web framework that you can use on ASP.NET or ASP.NET Core, and it looks like this. So we can just say get, and that means something that will going to respond to an HTTP GET. Then we put in a pattern for the URL, in this case a user ID, and then comes a lambda that is the implementation of whatever you want to do. And it's straightforward. In this case, we take out the user ID from the route itself, and then we just sort of check if the user is already there, and if they are, then we return the user and have it serialized to JSON or whatever. And if not, we return a not found. And some of you might be sort of going, okay, why is he showing us this? It's not hard. It's nothing difficult here. But that's the point. This is actually pretty simple. So just going with HTTP means that you're in a familiar territory and you have a lot of things already defined. Like, what should I do if I can't find the user? Well, you return not found, because that's already in the protocol. You don't have to make that stuff up yourself. Same kind of thing goes for a command. It's a post. Again, the Nancy code is pretty straightforward, I think. You just have a post to some URL, and then you have a lambda that handles that command. And on that first line where it says this.bind loyalty program user, we just try to deserialize the body of the post into a type called a loyalty program user. That's what's going on there. So that's model binding. You have the same thing in MVC Core if you prefer that, or probably in most web frameworks. And then you just do whatever you have to do in order to fulfill the command. Right. So switching gears a little bit. Let's go in and, oh, that has to move to the right screen. There we go, now you can see it right. Good. Okay, so let's just clear screen that. So we have a little demo thing here. And there's a client and a server in there. We're going to talk about the server now, and then we're going to look at the client towards the end. So let me just open up the code that we have here. That opened up on my screen here as well. There we go. Now you can see it too. Okay. So that's off to that side. Nope. There we go, there's my mouse. Anyway, so it's a slightly different example. We could imagine we have a shopping cart and it's really not an advanced shopping cart at all. We also have a get thing and we have a post thing here. So giving some user ID, given some user ID, we can post in some products that we get here by doing the model binding again, trying to deserialize from the body into an enumeral of products. And then you can just sort of interact with that, and it shouldn't really be that surprising. So I'm just going to start this, going into service, .NET run. And I guess we could also sort of mention that in order to set this up, there's not much to it. If you've seen ASP.NET Core in action, and you might have at other talks, then you'll know about the startup thing here where we sort of configure the whole application. And all we're doing here is basically just saying use Nancy to the app. And then you're ready to go. Then this Nancy module that we just saw, the cart, will be discovered and those routes will be set up so that we can hit those endpoints that we defined in the cart.cs. So we have that there. Okay, so we'll just check that we're up and running in the background. Yes, we are, and it's listening on localhost 5000. Good, so it's running now. And then I have some canned test requests that we're just going to fire off, just so that you can see exactly how these requests look. So first off, we have a post to port 5000, shopping cart, and then 500. That's just some user ID. And I'm going to say that we are posting some application JSON, and what we're posting is an array of products. So I'm putting a HoloLens and an Oculus Rift in my shopping cart apparently. So let's just send that off, and we get back a 200 OK, and then we actually get the contents of the shopping cart. Let's just see that in the code as well. Whoops, I wanted to go there. Make that a little bit bigger. So we did the post. We got, we read those products out from the bottom of the body of the request, and then we just return the cart however it looks for that user, and then just let Nancy deal with the serialization. And because we said we also had an accept header on the request saying we want application JSON back, then the web framework figures out how to serialize that in a proper manner. Again, these are things that we might look at and say, okay, we've seen content negotiation before, we've seen JSON serialization before, but my point really is that, yeah, that is the point. These things are things that kind of just work in your stacks. So you can think about the actual collaboration and not all the tech things. So I think that's why I think HTTP is a good starting point for a lot of things. Right, going back to the slides and turning the attention to talking about events. Because as I said earlier, this is probably the type of collaboration that should be preferred in a lot of cases. Events are asynchronous. So as I also stated earlier, it's past tense and it's a fact. It's something that has already happened. So in that sense, it's asynchronous by nature. And it follows a publish subscribe sort of pattern. So you have one side publishing the events, like, okay, there's a new user in the loyalty program. That's the loyalty program microservice saying that that's an event. It's happened, there's a new user. Then there might be other parts of the system that listens to those events. Or if you look at the special offers microservice that we had on the example slide from earlier, is there's a new offer and it looks like this. Tomorrow, this is going to be discounted. That's the publisher side, and then the loyalty program microservice can subscribe to that and say, okay, I want to react to those events. But it doesn't have to do it synchronously. It can do it on its own schedule. So the point is that it's already happened. So it's sort of up to the subscriber how quickly, how real time does this need to be. Maybe it doesn't need to be that real time, so you can have sort of a good lag there, and that evens out the load, and that makes that lowers your temporal coupling between these microservices, which is really good. And yet, this is pretty easy to implement with HTTP. So, on the microservice publishing the events, we want an event feed, and you can think about this as an Atom feed or an RSS feed where you subscribe to news or blog posts or whatever. It's the same idea. We just have an endpoint that is a GET endpoint and supports some kind of paging, and then you make requests like this or along these lines, and HTTP GET to /events, and you say, I want event number 100 through to 200, and then you get those back, and then you do whatever with them. So that's on the side of the publisher. You just need this event feed, and then you're kind of done in order of implementing the event-based collaboration. Well, almost. You need a little bit more because you need to actually raise these events. But sort of raising them, I tend to use that term, but it does sound like it's sort of shouting out to the world. There's a new loyalty program user. There is a new special offer. But it's not really true. If we implement it like this, then actually what's going on is just sort of the little microservice there with its own little database saying, okay, I'm going to put an event down there. It's already happened. I'm not going to tell anybody because I'm actually just storing the fact that this happened in a local database. And then it's only at the point where somebody asks for those events via that events endpoint that we actually give it to anybody. That's also sort of a nice thing coupling-wise. That means that the publisher doesn't know who the subscribers are. Somebody just calls that and anybody can do it, it's fine. That also means that subscribers don't have to be up at the point where the events are raised. When an event is raised, it just needs to store it in its own local database. So the microservice is self-contained. It can just raise the event. It's done. It's fine. So that's good. Yeah, I already said that. Looking at code, I think we're going to see that in the actual code in a little bit. So I'm just going to skip that and talk about how do you then actually subscribe to events. And you do that by just following this circle. So if we start at the top, the first thing as subscribers should do is fetch events. That means doing an HTTP GET to that endpoint with the events and sort of which events you want back. Then the next thing is that following the circle around, that you pass the events, so you get them back in some JSON format or whatever, so you have to read that and parse that out. And then you're ready to do whatever business logic you have to do. So within that loyalty program microservice, it's about figuring out, giving these new special offers that I vended out from the special offers microservice, who are the ones that I should notify about this? Who are the users that this is interesting for? And you can have all sorts of rules about that. Maybe you profile the users, know something about the interest, and you might also keep track of when did I last notify them about something. I don't want to bug them too much, and blah, blah, blah. All manner of rules. But that's within the loyalty program microservice. That is the one that knows about that, and that sort of makes sense that it's that one. The events are just coming from somewhere else that doesn't have to know all these things. Then, when you're done processing, you just keep track of how many events have I processed now, and then sleep for a while. And that sleep is somewhat interesting, because then after the sleep, you fetch again. So essentially, you're pulling on that events endpoint, like asking, are there any new events? Are there any new events? Are there any new events? And is that terrible? No, I don't think it is. Because for a good deal of use cases, that sleep time can be rather long, at least in sort of machine time, it can be rather long. Do you have to have up to the millisecond real-time responsiveness to notifying people about these special offers? You probably don't. Maybe it's once a day. Maybe you can run it just every morning. Maybe you can do it once every hour. And even if you're just down to something like once every hour, that's really slow for a machine, right? You're not going to notice it on your network. That's a business rule thing. So you have to understand, of course, the business capability being implemented in order to decide on that. But it is worth noticing that this can be really, really slow, actually. And for a lot of use cases, that is absolutely fine. That means that this is not going to be very noticeable on your sort of network traffic. It's just going to work fine. It's a pretty simple process. It's got some robustness built into it because you're going to repeat it anyway. You have that sleep period and then you're going to try again. So if at the time where a subscriber wants to look at some events, if the publisher at that point is down, so when the loyalty program microservice asks for new special offers, then if the special offers microservice is down, that's fine. It's just going to jump over to the sleep period, sleep a while, wake up, ask again. At that point, you will probably fix the other microservice, and you're good to go again. Of course, if it keeps being down, then you have a problem, but you will probably have other problems as well. Other than that, it shouldn't just be down forever. But it's expected that they are down sometimes, just because failures are expected, but also because, as we talked about, with lots and lots and lots of microservices, you're going to have lots and lots and lots of deployments. And you can do those with zero downtime, but you can also accept that there is a little bit of downtime in those deployments, and then design around it, have some robustness. And this just implicitly has that robustness in it, so that's kind of nice. Yeah. So subscribing to these events is part of a microservice, but it can be a different process. So it seems like something that belongs in sort of a background process. So the collaboration here is very much around HTTP. So each microservice has a web component to it. It's inside a web server. But this subscription you might want to pull out and have in something else. I think that's fine that you have microservices that span two operating system processes like that, and then you just deploy them together, and that's one logical unit. Okay, so demoing this part as well. Back to the same solution of code here. We also have, well, actually first let's notice we have the raising of the event here. So this is in the business logic, domain logic that I put here. And yes, it's really small and just demo size code that I have here. But we have some kind of an event store, and it's just a static dictionary really, but you can imagine that it was a dictionary, no, a database that you put it into, and it's persistent. And I say raise an event, and what I put into that is a products added to cart event. And that product added to carts event no, it's not that interesting. It really just takes a list of products that you list out, that these are the products that we just put in there, and then it has a sequence number that is counted up each time a new event is raised. Then the other part of this is the event feed. And as I said, it's just a very simple get endpoint in order to implement this event feed. And as you can see, it really is a small and simple one. You might need a little bit more around sort of bound conditions for the start and the end, and a couple of error cases. But this is essentially it, that you just pull out the start and the end from the query string of the request, and then you ask that event store to just return the events within this range, and then you just let the framework do the serialization and stuff. So again, it's a pretty simple idea. It's easy to implement, and you get some of the stuff that you sort of need around it, the infrastructure that you need around it to make it happen. You get that because you're just using a web framework. So that's a good thing about frameworks. They sort of remove the fluff from you. You just have to write the actual code. Right. So we have this running already. So I think we should be able to interact with this. There we go. So we already put something into a cart. Let's just check that it's still running and behind. Yeah, it's still running, and it got a request earlier to put something into a cart. So it should actually already have raised an event. So let's just see if we ask it for events number 0 through to number 10, then what do we get? And we get just the one event, because there is just one event. So that's also probably how you should implement this, that you can ask for whatever range you want, and then you just get back only up to whatever there was. Let's put a few more events in there, just for the sake of it. So I'm just going to, okay, I'm moving that over here. So we're back to looking at the cart, and I'm just going to add some more HoloLenses and some more Oculus Rifts to my cart. Let's do it a few times, and now I should have a few events in the feed. So if I still ask for the first 10 events, I expect that that's what I have out here. Oops, sorry. Yeah, 10 still. Then if I ask for those, I should get back sort of the larger list of events. We just see we have an event going from there and down to here, and it has sequence number 1, and it says, okay, there were some products added. And we have another one, and they look kind of similar because it's the same product that I added several times, but the sequence number goes up, and we see those going up to number 4. And if I only asked for like number 2 to number 3, then of course I get less back. Let's see if that works. I get number 2 and number 3 back. So not too surprising. But the point is that now you can use something that you already have in your stack, namely HTTP, in order to get this event-based system. Now you can ask yourself, why are we doing this over some sort of a queuing system? And there are definitely cases. In fact, there are a lot of cases where I think that is a good idea as well. But I don't think starting out with this precludes going to a queuing system at a later stage. And I think it's something that you can sensibly avoid for a time at least, because at least if you're in the cloud and everything is just happy-dappy and every technology just works, then that's fine. That's not always the reality. Sometimes you have to run things yourself, and sometimes things doesn't work quite as well as advertised. So the learning curve of running something like RabbitMQ or running Kafka is not always that easy. That's also something to learn. It's a technology that you have to learn to operate and run properly. So maybe you don't have to do that from day one. Maybe you don't have the scale where you actually need something from Kafka. I think you can scale up further with that than you probably in most cases can with this. But a lot of systems don't need to do that until further down the line. So my point is, just start out simple and you can actually get a long way. And this doesn't bar you from then going over to another technology. Because the essence here is that if you get the collaboration designed around the events, then you get the asynchronicity. I think that's the right word. I can't talk. You get the asynchronous collaboration, and that's the essential bit. Then sort of over time, yes, you can introduce another technology and switch it over. But this is a good starting point, and you might not have to move beyond the starting point. And then you saved the time of learning that technology. And I think sort of something that is sometimes overlooked as well is that queuing technologies can introduce a single point of failure. Because let's look at something like Rabbit. Where do you put those events that you put on RabbitMQ? You put them into a Rabbit cluster. Yes, it's clustered, but it's one central point where everything goes through. So now you have a single point of failure. That's not really the case here. So you avoid that as well. Right. Back to slides. So a little recap of the example here. We've seen event-based collaboration in the top left-hand corner. We've seen some query and command-based collaboration in the bottom left-hand corner. And we've seen them all implemented over HTTP. Just going to repeat that. We have the 3 different styles. So repeating some of what I've already said, commands and queries are synchronous. And that means that the caller sees errors. If you query for something and the other one is down or fails, however, then the caller sees those errors, and they have to decide what to do. You can't make the server side be the one responsible for dealing with errors, because they might not even see the request. It might be the network that's broken. So it has to be the caller that deals with that. And maybe sometimes that's kind of the obvious way of doing things. So it can be good that you're doing that, because then you are into code that you can easily understand. You get sort of consistency in the sense that we usually think about it a lot here, because it's synchronous. You ask for something, you get it back. So there's some sort of ease of use in doing this, but there's also some coupling, and especially the temporal coupling. That is, that both services has to be up, can really bite you as you go along. It's also slow. Again, this is something we've said for years and years and years with all distributed systems, and it is true that making remote calls is slow compared to doing it inside of your own process. And sort of the lure of doing these kinds of collaborations with commands and queries is that it looks like just a method call, but it really isn't. It's not stable in nearly the same way, and it's not nearly as fast. So beware of that. Events, on the other hand, are asynchronous, which means that the point in time where you feel that that slowness of the remoteness and the instability of doing remote calls sort of moves. It's not at the point where the event is raised. It's at the subscriber. So the subscriber has to be the one dealing with errors, and it's for the same reason. The subscriber is now the one making the call, so it's the only one that is in a position to deal with any errors. But I think that's a good thing around these things. It makes sense that it's the subscriber that knows why it needs the events. It's the subscriber that knows how critical this is. So it's the subscriber that's able to deal with errors and say, how quickly should I retry? What should my compensating actions be? What do I need to do around this in order to deal with errors? The one raising the event doesn't know that. You have eventual consistency with this, and I think that's worth pointing out, because eventually consistency can be a double-edged sword. I find it's really neat when it works. That you just sort of have these things happening, and then eventually everybody will catch up in an asynchronous fashion, and things will be consistent again. But it's also not always the way we intuitively think about things. So we do run into situations where it's kind of surprising to people that something was eventually consistent. And we can come up with sort of good scenarios where nobody will ever notice that it's eventually consistent. But I think it's worth being aware of that not all cases sort of intuitively fit into that. And that's worth at least thinking about. How can you then make it look consistent? And I think there are ways that you can do that. Maybe you can redesign the workflow. Maybe you can make the communication back to the user slightly different, so that it becomes obvious that you're doing eventual consistency. But I think it's something we should just be upfront about, that this is something we need in order to get the stability and the scalability in these types of systems, and then design it into the features as well. And that's all doable. And you have much less temporal coupling with this than you have with the other two styles of collaboration, which I think I have labored already. Now, as time passes with these microservice systems, they evolve, as I said. Then kind of this tends to happen over time, maybe by accident or maybe on purpose. It probably needs some guidance in order to happen. And what it's meant to illustrate that is that some microservices are more closely related than others. Some are more cohesive than others, and that's okay. And there is, just as with objects, there's the duality of coupling and cohesion. I think that's true for microservices as well. So the colored circles up there are meant to be groups of services. In one case, it's group of service, singular. We just have one in there. These could be bounded contexts if you're doing domain-driven design. And then within those bounded contexts, it turns out you have different capabilities, and then you might implement one capability in one microservice, another capability in another microservice. That's what you have illustrated here, here, here. So that goes back to the idea behind the loyalty program being something that at a first approximation might be one service. Then you might figure out, oh, this is a whole bounding context with several capabilities inside of them. But these are more cohesive than they are sort of with the rest of the system. So within those, I tend to accept higher coupling, meaning that within a bounded context, I think it can be okay to use command and query-based collaboration a little bit more, whereas between these bounded contexts, between these groups of services, so those are the red arrows, I strongly prefer event-based collaboration, because these are things that are further apart in the system. So it's worth is if one brings the other down. It's also things that are naturally further apart in the domain, so eventually consistency is more natural. So I recommend the event-based collaboration as much as we can do it, but especially between the bounded contexts, and I think that's worth noticing as well. Another thing you can sort of get from the illustration of this is that you don't have to do it. You don't have to do the sizes of these microservices uniformly across the whole system. It can be fine that you sort of identify that the green area of that bounded context kind of suits just within one big solution, and it's okay. Then you can do sort of smaller microservices in another part. You still have the collaboration going on, and you don't really have to notice from the outside that one green one is one big thing. You just have event-based collaboration going on with it, and it's fine. So, in closing, you should prefer event-based collaboration. And we are done early, I can see, so we do have time for questions if there are any. And if not, then you just get a bit more time for your break.